19 billion years. That's a problem.
We're very close to having a kind of contradiction between the ages of the stars and the age of the universe. This would be quite embarrassing, because you really shouldn't be older than your mother.
Clearly, if the universe is 10 or 12 billion years old, then there can't be stars in the universe that are 15 or 17 billion years old. That's not logical, at least if the entire Big Bang theory is right or even close to being right.
Wendy Friedman is well aware of the dilemma. She knows that, like many other puzzles about the universe, this one will probably be around for a while.
I mean, anytime you get a new tool, you get data that are better quality than were possible to obtain in the past.
Yeah.
You learn new things, and yes, sometimes leads to confusion because there aren't answers for all of the questions that are being raised. But it's a healthy aspect of science and how science proceeds.
There's more to the universe than meets the eye. We can see only a small part of what's going on out there. What we call visible light, the rainbow from red to violet, is a small slice of a larger spectrum. But there are other ways of seeing. With the right technology, you can look at the world in everything from X-rays to infrared to radio waves. In the last few decades, the new tools have brought a previously hidden universe into view. Take the sun. Nothing to do but roll around heaven all day, right? But by using the X-ray part of the spectrum, astronomers can see the sun is a very busy place. Pictures made by X-ray detectors show there's a cauldron of nuclear reactions boiling beneath its surface. Using film sensitive to ultraviolet, we can see great plumes of superheated gases rising from the sun's surface. Our well-behaved, friendly neighborhood star is a continuing, self-contained thermonuclear explosion.
It's a high-energy astronomy where you really see that the universe is a violent place. It's not just made up of these good citizen stars that sit quietly fusing their hydrogen into helium.
NASA is looking at the lower end of the spectrum, infrared light. Infrared is absorbed by moisture in the Earth's atmosphere. So infrared telescopes are mounted on planes to lift them above the clouds.
Just like fog lights on your car will enable you to see deeper, in the infrared you can see deeper into the universe. We warm human bodies shine in the infrared. Anything at my temperature in the universe is emitting planets, comets, other bodies.
The star-forming regions of the universe are often hidden from view by dust clouds, until infrared astronomy allowed us a way in. Now we can see clouds of frigid hydrogen gas condensing and starting to heat up as stars. The sky in the infrared is a strange and wonderful place. Once we learned where to look, we could peek into these stellar nurseries and snap some baby pictures. This is Hubble's view of the Eagle Nebula. The bright spots on the edge of these monstrous pillars of gas are brand new suns. But as spectacular as the pictures are, scientists owe much of their understanding of the universe to radio static, a whisper from the sky.
If you're listening to the universe with a radio telescope, it would mainly be a hissing sound. It sounds like steam escaping from a radiator.
They heard it first by accident. In 1965, researchers at Bell Telephone Laboratories had built a powerful listening station to hear signals from the first of America's communication satellites. But they were distracted by an ultra-low frequency hiss from everywhere in the sky. What they were picking up was energy from the bright flash that started the universe, an echo of the Big Bang itself.
Radio astronomy was the second big window we opened on the universe. The first big window was Galileo going and putting a telescope to his eyes and seeing what he could see with his own eyes, and then with film eventually. The next big step was radio astronomy. It's a great step forward in terms of discovering new things and understanding new things.
The discovery of the cosmic background radiation was a fatal blow to those who wanted to believe in an eternal universe. The Big Bang proponents had won. But the cosmic background radiation seemed to be smooth and even, coming from everywhere in the sky. Just what you'd expect from a universe that began from a single point. But then, why weren't the stars spread evenly through space? Galaxies should be moving steadily outward as the universe expands. Each should be moving away from all others like raisins in a rising loaf of bread.
Astronomers had thought that the universe was sort of expanding uniformly and the galaxies were just going along, and that the only motion we should see is the Earth going around the Sun and the Sun going around the galaxy. But in fact what we saw was that the largest motion of all was the galaxy itself moving. And that really surprised astronomers, and the only conclusion we could come to was that something was causing the galaxy to move away from just the simple expansion of the universe. And after thinking about it for a while, the conclusion was that there must be a large group of galaxies near us.
When astronomers plot the position of galaxies in their computers, they find filaments and clusters and walls of galaxies. How could that be if radio telescopes were saying the energy of the Big Bang was evenly spread across the sky?
There had to be some seeds at the beginning. There had to be some small lumps in the early universe that are going to grow to create the structure.
So Smoot went looking for irregularities in the background radiation to show that the Big Bang explosion was uneven. In 1989, his instrument package went up on a satellite, the Cosmic Background Explorer. It found subtle variations in the energy left over from the moment of creation. Announced in 1992, it was one of the momentous discoveries of the century. The universe made sense again. Smoot later told the press these wrinkles in the cosmic background radiation were the largest structures ever seen and the oldest. He told reporters that it was like seeing God.
And that's the one that the press grabbed on because that's the one people could relate to. And that got spread all over and got much more attention, including people from philosophy and religion coming in and asking questions.
But if researchers could finally explain why there are stars and galaxies and collections of galaxies, that didn't solve their other major problem. It's a little like the old childhood rhyme. The other day upon the stair, I met a man who wasn't there. He wasn't there again today. Oh, how I wish he'd stay away.
The problem is that we know that at least 90% of the universe is something we don't know what it is.
In the late 1970s, astronomer Vera Rubin and her associates noticed something peculiar on the outer edges of spiral galaxies like our own. Like flotsam caught in a whirlpool, stars on the fringes of galaxies should be moving more slowly than stars at the center. But what Rubin saw appeared to defy the laws of physics. The stars on the edge were moving just as fast as those in the middle.
We live, sort of 2/3 of the way, we being the Earth, about 2/3 of the way out from the center of our galaxy, and we're orbiting at 500,000 miles an hour. That's pretty fast.
Faster than it should be. Such velocities could only be caused by an enormous gravitational pull, which requires more matter than anyone had detected out there. A lot more.
It was a shock to learn